It's not sexy, and in fact there's not a huge amount of physics involved. But it turns out that as long as the acceleration of an object is constant, there are relationships over time, a given time interval, that link up what's happening with the velocity and the position at the beginning of the interval and the velocity at the position at the end of the interval, and the size of the interval and the size of the acceleration. There's the relationships that link up those variables to one another in a very kind of useful way. So for instance, if we take a velocity versus time grid and we draw in a constant acceleration situation, which is to say a velocity function that's linear, and then we go ahead and pick any old time interval at all and look to see what the velocity changes over that time interval, we can take the ratio of those two to come up with something whose units are meters per second, which is what we call the acceleration. And if we do a little bit of mathematics, we can come up with this relationship that says the velocity at a second point in time, which would be at the end of the time interval, equals the velocity at some initial point in time, at the beginning of the time interval, plus a delta t, where a is the acceleration and t is the time interval. If you think a little bit about the units, what you realize is that the a delta t, meters per second times seconds, gives you the units meters per second, which is to say it gives you the units of a velocity. So what you're really looking at here is a relationship that effectively says if you know how the velocity changes due to the fact that the body's accelerating, that's the a delta t part, and you add it to what the velocity was at the beginning of the interval, you will end up with what the velocity was at the end of the interval. Okay? This relationship is always true if the acceleration is constant. It doesn't matter what time interval you choose. It turns out that there are other relationships aside from this one, which are also true and also follow as a consequence of constant acceleration. The second one here does not have the velocity at the end of the interval in it. It has all the other variables, all the other parameters. The last one does not have the time interval in it, but it has all the others. In other words, what you have are a set of equations that are predicated on constant acceleration that allow you to figure out what's going on with a body that's accelerating, assuming that you're given enough information. These relationships are collectively called the kinematic equations, and this is what you're going to be ending up dealing with first in a one-dimensional situation and then down the line in a two-dimensional situation. So you have a couple of homework problems to do. I would appreciate it if you would go to them and do them now. Thank you very much.